In this simulation, we have a simulation for Ohm's law. You can see by this formula V equals IR that these components are linearly proportional. As you increase the voltage, it increases the number of batteries in the circuit and current increases proportionally. As you decrease the voltage, it follows likewise. Then if you increase resistance, current decreases, and if you decrease it, current increases. You'll notice current is represented by these arrows down here, and resistance is represented by these black dots in our model resistor here.
In this simulation of Ohm's law, we have three variables. V is for voltage. It is the electrical pressure that pushes electrons through a circuit. Its units are volts. I is for current. It is the rate of flow of electrons through a circuit. Its units are amps. R is for resistance. It opposes and slows the flow of current through a circuit. Its units are ohms. The difference between an object's resistance and resistivity is that resistance depends on the object's geometry, such as its size and shape. Resistivity is an intrinsic property of the material, where each object opposes the flow of current regardless of its size and shape. For example, all copper materials have the same resistivity, but its resistance can be affected by changing the copper's geometry. The heat developed in a circuit with copper wire is the electrical resistance to the movement of electrons flowing. For some materials, they can conduct electricity with zero resistance if it is below a certain temperature. They are known as superconductors. In these superconductors, if we took away the battery providing the voltage, the current in the wire would stay forever with no loss of current. Conducting electricity with zero resistance is beneficial because it eliminates energy loss as heat, and there is no voltage drop across the material. Superconductors don't follow Ohm's law because if resistance equals zero, then voltage equals zero, and we can no longer calculate current. This simulation is essentially an Ohm's law calculator. As long as we know two of the three parameters, we can rearrange Ohm's law to calculate the unknown variable. For example, if we know that our voltage is 9 volts and our total resistance is 30 ohms, we can input these values into the simulation and it would calculate a current of 300 milliamps. Ohm's law is useful in a real-life situation because we are not able to measure individual components in a live circuit without disconnecting everything.